Good afternoon, everyone. We are the Group 4 and today we will report about flame test. The heat from a laboratory burner will cause the ions of some elements to give off light. Electrons will absorb the heat energy from the flame and will jump to a higher energy level. When the electrons return to their original energy levels, this absorbed energy is released as light. Different elements absorb and release different amounts of energy and thus produce different kinds of light. This light may be visible or invisible, infrared or ultraviolet radiation. Analysis of this light can be used to identify elements and molecules. A flame test is a procedure used to test qualitatively for the presence of certain metals and chemical compounds. When the compound to be studied is excited by heating it in a flame, the metal ions will begin to emit light. Based on the emission spectrum of the element, the compound will turn the flame a characteristic color. This technique of using certain chemical compounds to color flames is widely used in pyrotechnics to produce the range of colors seen in a firework display. The materials used in the experiment are 10 ml dilute solutions of the following: barium chloride, calcium chloride, lithium chloride, potassium chloride, sodium chloride, strontium chloride, an unknown solution, 7 wood splints, 1 Bunsen burner, and safety goggles. In the next slide, a video is shown to let us know how the experiment is done.
Okay, welcome to our flame test lab. I'm going to show you folks how to light a Bunsen burner today, and we're also going to do our flame test experiment for you guys in case you weren't here, or when you are here, you guys will get a good idea as to what exactly you need to do when you are here. So we have our lab. You'll notice that there are some nice instructions here for you folks to follow. You're going to have to create your own data table today, and then there are some nice problem-solving questions you are going to have to take care of when you get home. You need to think about these. Just don't, give me a third grade quick little answer here. So number one, research to determine what causes the flame color. I really want you to consider what causes that color from the flame, and don't write something like, well, it's the chemicals reacting. Please think about it. We've talked about it in class, and you might want to do a little bit of research on your own, and so on down the paper. Okay? So, to light a Bunsen burner, let's just quickly give you a quick rundown on that. You'll have a gas jet here, and to light a burner, what you want to do is you want to turn the gas jet 1/4 of a turn. And the gas is now on full blast. If you turn it all the way over to the other side, you've just turned the gas on and off again, and that's not going to help us. So turn it 1/4 of a turn. Now you're going to light your lighter and bring it up alongside the barrel, and you've lit your flame. It's pretty simple. The air intakes on the bottom should be wide open, as they are here. That gives us a nice light blue flame, and for this experiment that's important because we want very little color in that flame. Now, at least color caused by the burning natural gas. To turn this off, you just turn it the rest of the way, and it shuts off. So once again, we'll turn that on and leave it on. Once again, make sure your safety glasses are on throughout the duration of this experiment. So there's our flame. We're going to use that, and we are also going to use the following salts. We have from the right to our left, we have a potassium salt, a copper salt, a strontium salt, a sodium salt, a barium salt, a calcium salt, and it looks like a lithium salt. Those are all chlorides of those salts. We also have 2 unknowns sitting in the back there, and a beaker full of distilled water with some cotton swabs. And our waste container we'll be using as well. So let's get the burner flame in focus here, and let's go through the procedure. What you're going to do is you're going to want to grab a cotton swab. Let's zoom back out a little bit. And for that cotton swab, we want to use a clean cotton swab each time. And the only thing that will enter into your distilled water beaker will be the tip of a clean cotton swab. We'll put that in the distilled water, get it nice and wet, and then we will take our first unknown. In this case, it's going to be our potassium salt, and we will go ahead and touch this to the salt so we get some salt on the moistened tip of our cotton swab. We'll then put that in the flame, and we will examine the color there, and we'll record that in our data table. Now please don't ask me, Mr. Hermer, what color is that flame? That's for you and your partner to decide. Now when you're finished, go ahead and take that cotton swab and just place it right in the waste beaker. You don't want to use that again. You're going to get a clean cotton swab for each test. Okay, so potassium is finished. We'll put that off to the side. And the next salt we'll do is copper. So we'll grab a clean cotton swab again, moisten the tip, and then we'll touch that to the copper salt. We'll get some of that copper salt on there. Oops. There we go. Not sure if you saw that, but we have enough of the copper salt on that swab. And we'll put that in the burner flame. And once again, let's get that in focus here for us. Put that in the burner flame, and you folks will decide upon the color of that flame. Alright. Got that for copper, folks? We're done. Put that into our waste container, and we'll repeat the process for our next salt, which is going to be strontium this time. Okay, so we'll get a clean cotton swab, dip it in distilled water, and we'll touch it to the surface of our strontium salt, and then we'll put that in our flame. And once again, I don't know how well these colors are showing up on the video. It's enough of an observation for you to determine the color for the strontium salt. Okay, we're finished with that. Place that in our waste container. And it looks like we'll move on to sodium next. Take our new cotton swab, dip it in our distilled water, touch that to the surface of our sodium. You can see we have some sodium salt on that tip. Put that in the flame, and we get another color there. Okay. Alrighty, throw that in our waste container, and now we'll move on to our barium salt. So let's get our Q-tip moistened, and get some barium salt on there. Sort of fun, isn't it? That in our flame. Okay. Make your observation. Okay. Get rid of that. Barium's finished. And we're going to go on to calcium. Next in our Q-tip. And we'll get some calcium salt on the tip. And we'll do that one. And then our final known looks like it's lithium. It's a little hygroscopic. It's gotten a little moist over the past couple of days. Get that wet. And we'll put that in our flame. There we go. Okay, so that was our lithium salt. Okay, fill that in our waste container, and now we'll do our two unknowns. This is unknown number 1, so it's going to be one of those we just tested. There's the tip of our Q-tip, and we'll get some of the unknown salt on it. Test our unknown. It's your job to decide what that unknown is. That's unknown number 1, folks. Okay. And then we'll put that off to the side. And this is our unknown number 2. We'll handle that the same way. We'll get our Q-tip moistened. And get that nice and coated with our unknown number 2. And that's unknown number 2's flame test color. Alright, so now it's up to you. to determine what those two unknowns are, unknown 1 and 2, based on their flame test color. Remember, you have to complete your lab report, so take some time doing that, and that'll be due next time we see each other. Remember to shut down your burner and clean up your area. To shut the burner off, remember, we'll just go ahead and turn that gas valve over. You guys can return your safety glasses to the safety glass cabinet. Make sure they're put away neatly so that they can be sanitized properly for our next class. I think that's about it. Have a great day. Bye-bye.
So, as you can see sa video, ilahang gigamit is Q-tips or cotton buds. Oo. And, same lang gyapon siya sa procedure nga katong wood splint ang ginagamit. It just that nag-differ lang sila sa materials na gibuhat, pero same naman gyapon ang results. Ang ano lang, pinagkaibahan lang dito sa sa katong Q-tips ang gigamit, solid ang ilahang solution kanang powdered. Ang una nila gibuhat is gimoistan sa nila ang Q-tips, gibasa nila para pag dip nila sa solution, sa powdered solution, magdikit siya ba. Also, purpose pod sa pag dip sa water katong Q-tips is that para pag place nila sa flame dili siya masunog, kasi ang main goal gid ani nga kaning flame test is not to sunog the kanang material nga imong ginagamit. It's just that kanang mag-observe og mga color unsa ilahang mga kanang anong solution ganon. And yeah, so mag-move on na tatong sa schematic diagram sa atoang procedure sa pag-perform sa atoang flame test. So, first of all, safety is always first gid, and during sa pag-perform sa flame test, we need to wear goggles to protect our eyes. But kuan pud ni siya kanang additional. For girls nga kanang naay taas nga hair, you need to secure your hair with a tie. I-tie niyo siya sa back, or like you have like katong cap, like I don't know what it is called kay nakalimot ko. Yeah, dili lang po ni siya for girls, sa mga guys po na kanang naay long hair, or like me nga kanang ingani naagid na tendency nga kanang masunog gid ang hair. So you need to secure your hair and move on. After kanang wearing kanang protection goggles, tied your hair, obtain a wood splint. Di ba sa video ang gamit kay kanang cotton buds, dire kay wood splint. Obtain a wood splint and barium chloride solution. Diri pod nga kanang sa solution pod, diri sa kanang sa wood splint, dili na siya powdered kumpara sa tong sa video. Ano na siya kanang dissolve na siya sa kanang iodized na water. Like, sana ilang tawag. Basta kato na iodized water. And after obtaining kanang ang wood splint og ang imahang solution, dip the wood splint, imahang kanang isok ang wood splint sa solution for like 1 to 2 minutes. Pero I saw a video sa YouTube na they soak it for like overnight or like whole day. Siguro kay para mas daghan ma-absorb na solution ang wood splint. Pero still, pareha lang man japon ang result pag ano na nimo sa ano, di ba? It's just that mas daghan lang na-absorb, siguro mas klaro gid ang result, di ba? After habang ginasok to nimo imong wood splint sa solution, prepare your Bunsen burner, like open i-open ng i-open, pasigahon ng ipasigahon, di ba? Lit na Bunsen burner after ka nang na-prepare na nimo ang imuhang Bunsen burner, pwede na nimo kuhaon ang wood splint and then kanang igunitan siya sa tip where kanang dili dito sa may kanang gipag babaran nimo ha, sa may katong wala gibabaran, and then place it on top of the hottest parts of flame, and then observe and kung unsa man ang kanang color nga ni gawas, record the color of the flame, and then same lang po siya, repeat steps 2 to 6 with kanang sa remaining pa nimo nga mga chloride solution na po, sa copper chloride, sa sodium chloride, ganun lang, same lang yapon sa katong pag-dip, prepare ang imuhang Bunsen burner, i-place nimo sa i-place nimo sa hottest part sa flame, and yeah, observe lang yapon, record kung sa ang mga nagawas na mga colors, unsa. And then, after that, obtain an unknown solution, and then record the number of your unknown. After that, soak na pud ka ulit sa imuhang wood splint sa unknown solution. So, mao lang to siya, very easy, diba? And habang ginatan-aw na ko ang video sa mga kanang how they perform flame test, very siya kanang amazing, kay kanang color good, tapos also sa pag place good nimo sa hottest part sa katong sa flame, pag diba imong wood split, i-place nimo siya sa hottest part sa imong wood split, pero do not burn it, kay dili man gid ingat to atong intention, diba? It is just to observe and record the color nga kanang iyahang na produce. It is not to kanang sunugon gid siya kanang diba? After that, after nimo nang kanang na-observe na, pwede nimo siya kanang ipalungon or like i-dispose na nimo katong wood splint, diba? So that is all sa procedure, and let us move on sa next na po.
So for the guide questions, number 1, do you think we can use the flame test to determine the identity of unknowns in a mixture? Why or why not? For the answer, yes, because different tests have different colors. If these colors are the unknown of the mixture, it shows that the compound is in the mixture because of the colors are the same. The flame test is used to visually determine the identity of unknown metal or metalloid ion based on the characteristic color. The heat of the flame converts the metal ions into atoms, which become excited and emit visible light. For number 2, why do different chemicals emit different colors of light? For the answer, because no two elements have the same set of energy level. Different elements emit different colors of light. Energy is released when electrons move from higher energy levels to lower ones or visible light.
So for our number 3, why do you think the chemicals have to be heated in the flame first before the colored light is emitted? So the heat gives the electrons energy, moving them to the excited state. Then you take the heat off, snapping the electrons back to ground state, releasing the energy that was absorbed, causing light to be emitted. The chemicals have to be heated in the flame first before the colored light is emitted, because the electrons get excited when they were heated by an electric field, and that is when they jump to a higher energy shell and emit light. So, when flames produce or create an element signature emission spectrum, regions of particles with the same energy transmissions appear to form a continuous band of color, which is dependent on the energy emitted by each electron as it returns to its ground state. And for our number 4, fireworks are made by combining metals with explosive materials. Using your data, which metal or metals do you predict would be used in the production of green fireworks? Based on the data, the metal that we predicted to be used in the production of green fireworks is a barium chloride. So why barium and chlorine should be mixed to produce barium chloride? This is because ang barium is unstable siya in room temperature, kaya kailangan natin siya i-mix or i-combine with chlorine, which is a more stable compound that was released in the heat of the burning pyrotechnic composition para mabuo ang barium chloride that can produce or provide green colors.
And for the table 1, the flame color produced of the metal ion sodium is yellow, while for the potassium is lilac, and for the calcium is orange-red, and in lithium and strontium is red, while in the copper is blue-green.
So for conclusion, to conclude all in all, based on the experiments, that when various elements are exposed to a flame, they produce diverse colors, the presence of which indicates atomic emission. There is also a connection between the wavelength of an element and the color it creates.